Welcome to this presentation on layered entire architecture. Today we will explore the components and interactions that make up this widely used software architectural pattern. Let's dive in. So what is layered architecture? It is a design pattern where the application is divided into separate layers, each with its own specific role and responsibility. This separation of concerns allows for better scalability, maintainability, and flexibility, making it easier to manage complex systems. In a typical entire architecture, there are four key layers: the presentation layer, which manages user interfaces, the business logic layer, responsible for core application logic, the data access layer, which handles communication with the database. Finally, the database layer, where data is stored and retrieved. Let's start with the presentation layer. This layer is responsible for the user interface and user interaction. It handles tasks like displaying data and collecting user input. Technologies such as HTML, CSS, JavaScript, and frameworks like React or Angular are commonly used here. A great example would be the web or mobile interfaces of an online store. Next, we have the business logic layer, which sits at the heart of the application. This layer processes the core application rules such as data validation, business rule enforcement, and processing user requests. Technologies like Java, Python, Node.js, or C++ are typically used in this layer. A real-life example would be an order validation system in an e-commerce application. The data access layer is responsible for handling all interactions with the database. It executes queries, manages transactions, and ensures data retrieval and updates. Technologies like object relational mapping (ORM) frameworks such as Hibernate or Entity Framework are often used. A good example would be fetching customer details or product information from the database. The database layer is where data is stored. This layer ensures data persistence and is where operations like indexing and backups occur. It can involve both relational databases like MySQL or PostgreSQL or NoSQL databases like MongoDB. Think of it as the underlying data storage for applications such as customer data in an e-commerce system. Now let's Now how does layered architecture fit into high-level design? Here's a simple breakdown. Define the different layers: presentation, business, data access, and database. Specify the responsibilities for each layer. Indicate how data and control flow between the layers. Ensure scalability and flexibility in the design to handle future changes. Here's an example of how this might work in a real-world e-commerce system. The presentation layer would include the user-facing elements like the website or mobile app. The business logic layer would handle things like order processing and payment calculations. The data access layer would provide APIs to fetch product details, while the database layer stores customer orders and product catalogs. So why should we use layered architecture? Here are some of its benefits. Separation of concern. Each layer is focused on a specific aspect, making development and debugging simpler. Reusability. Layers can be reused across projects, saving development time. Scalability. Each layer can be scaled independently depending on the needs of the application. Flexibility. You can use, update, or replace layers without disrupting the entire system. Testability. With clearly defined layers, it's easier to test each component in isolation. While there are many benefits, layered architecture also comes with challenges. Performance overhead. The use of multiple layers can introduce some latency due to data passing through each layer. Complexity. Managing dependencies between layers can become complex in large systems. Rigidity. The structure can make it difficult to rapidly prototype or adapt to quick changes. Over-engineering. For smaller projects, this architecture might be more complex than necessary. Let's look at a couple of real-world examples where layered architecture is used. In a banking system, the presentation layer could be a mobile or web application. The business logic layer would process transactions, while the data access layer would handle APIs and the database layer would manage core banking data. For an e-commerce application, the presentation layer would be the online store interface. The business logic layer handles order processing. The data access layer interacts with product data, and the database layer stores customer orders. To conclude, layered architecture is a powerful design pattern that helps build scalable, maintainable, and testable applications. By separating concerns into distinct layers, it provides a clean structure for both development and maintenance. Understanding how each layer interacts will help us implement this architecture e- effectively in our own projects. Now I would like to open the floor for any questions. Feel free to ask about anything related to layered architecture, its components, or its implementation. I am happy to clarify any doubts.